Rotary snowplow. This is a rotary snowplow. A regular plow just hits it and stops. A giant spinning wheel full of curved blades mounted on the front of a rail car. It doesn't push the snow, it chews it, spinning fast enough to fling solid snowdrifts clear off the tracks in seconds. It had no engine of its own to move. A locomotive had to push it from behind, but once it hit a drift, it carved straight through terrain that would have stopped a train for weeks. Railroads through the Rockies and the Canadian mountains still use rotary plows today. The basic design from the 1880s barely changed. Long before cars, long before tram, there was this. A regular horse-drawn city carriage, the kind that bounced over cobblestones, fitted with metal wheels and placed onto iron rails. The idea was simple. City streets in the 1830s were brutal. Horses struggled, wheels broke. But put that same carriage on rails and suddenly the ride is smooth. The horse pulls less weight and more passengers fit per trip. Katoomba Scenic Railway. Now go to the Blue Mountains, Australia. A railway built in the 1880s. Not for tourists, but for coal. Miners needed a way to haul coal out of the Jameson Valley, so they built a track. In 1945, it reopened as a tourist ride, and now thousands of people a day ride almost straight down into a rainforest valley on a railway built for coal carts, never meant for people at all. The Holman train. And then there are the ones history barely kept records of. The Holman train is one of those footnotes, an early experimental rail design that never made it past the prototype stage, the kind of project that gets a paragraph in an old engineering journal and then disappeared. Wuppertal Schwebebahn, 1901, Germany. An engineer looks at the crowded streets of Wuppertal and asks, why does a train need to touch the ground at all? The Schwebebahn is a suspended railway. The entire train hangs from a rail mounted above the streets, gliding over rooftops, rivers, and traffic that has nothing to do with it. Bennie Railplane, Scotland. Brennan had a stranger idea. Forget two rails, use one rail, and balance the entire train using gyroscopes. In the early 1900s, he built it. Two massive spinning gyroscopes inside the carriage, fighting to keep the whole vehicle upright on a single thin rail, the same way a spinning top refuses to fall over. It worked. He demonstrated it to British military officials who were stunned watching a train balance on what looked like a tightrope. Schienenzeppelin, Germany, 1931. A massive aluminum railcar shaped like an airship with a giant aircraft propeller bolted to the back, screaming through the German countryside. On June 21st, 1931, it hit 230 kilometers per hour on regular rail track. But there was an obvious problem nobody could ignore. A giant spinning propeller at the back of a passenger train at station height near platforms full of people. It was terrifying, and it was never going to be allowed near a station. Armored trains. Not every train is built for comfort. Some are built to survive a battlefield. Armored trains became a fixture of both world wars. Locomotives wrapped in steel plate, fitted with artillery turrets and machine gun nests. Rolling fortresses that could move troops, supplies, and firepower along entire front line. Galloping Goose number 7. Now picture a railroad in 1930s Colorado that is flat broke. The Rio Grande Southern can't afford a real train, but it still has obligations. Bamboo train, Cambodia. After decades of war and the collapse of formal infrastructure under the Khmer Rouge, had railway tracks, but no any actual trains, so locals built their own. A flat bamboo platform, two simple axles, a small motor scavenged from a motorcycle or farm equipment. That's it. The Michelin Railcar, the tire company. Yes, Michelin. In the 1930s, they built it. The Michelin, pneumatic rubber tires on a railcar tested across France. Sonic Wind number 1. This one isn't really a train, it's a rocket sled, but it ran on rails, so it counts. In the 1950s, U.S. Air Force Colonel John Stapp used Sonic Wind number 1 at Holloman Air Force. He wrote it himself. General Motors Aérotrain GM looks at trains and decides they need a redesign, using the same lightweight construction and styling language as their buses. The Aérotrain looked like the future, sleek, low, futuristic curves, marketed hard as the train of tomorrow. M497 Black Beetle, New York, 1966. An engineer named Don Wetzel had an idea that sounds almost like a joke. Take a normal diesel rail car and bolt two jet engines from a fighter plane onto the roof. They actually built it. Two General Electric J47 jet engines mounted on top of a standard Bud Rail diesel car running on ordinary New York Central track in Ohio. It hit 183.85 miles per hour on regular rail in 1966. That record for conventional, non-electrified tracks stood for decades. It never went anywhere near commercial production. The cost and impracticality were obvious even at the time. The jets were removed. The car went back to normal passenger service. The UAC TurboTrain, United Aircraft Corporation, an aerospace company, decided to bring jet-age engineering to passenger rail in the late 1960s. The TurboTrain ran on gas turbine engines, the same basic principle as a jet, and used a tilting carriage body to take curves faster without throwing passengers sideways. It ran in both the US and Canada, genuinely fast for its era. Then the 1970s oil crisis hit. Turbine engines drink fuel at a rate diesel engines simply don't. Operating costs spiraled, and one by one, operators retired their TurboTrain fleets. A brilliant idea, killed by an oil price shock nobody saw coming. Jean Bertin's Aérotrain, France, 1960s. The Aérotrain rode on a cushion of air, hovering just above a concrete guideway shaped like an inverted T-beam, propelled by aircraft engines. No friction, no steel wheels, just air and thrust. It worked stunningly well. Test runs through the French countryside hit speeds over 400 kilometers per hour, numbers that wouldn't be matched by conventional rail for years. And then, in the mid-1970s, the French government made its choice and chose the steel-wheel TGV instead. The Aérotrain project was cancelled. Jean Bertin died shortly after in 1975.